Professor Bansal. Good afternoon. So can you hear me,
Yes, sir.
Professor Bansal? Good afternoon, Professor Bansal. सर अनम्यूट कर लीजिए.
Yeah. Can you hear me now?
Yes, it is
Yeah.
okay.
Okay. Thank you.
So this session will be taken by Professor Jagdish Chand Bansal. He is Associate Professor in the Department of Mathematics in South Asian University, New Delhi, which is international university established by the SAARC countries. So Dr. Jagdish Chand Bansal is Associate Professor at South Asian University and visiting faculty at Maths and Computer Science, Liverpool Hope University, UK. Dr. Bansal has obtained his PhD in mathematics from IIT Roorkee. Before joining South Asian University, he has worked as assistant professor at Atal Bihari Vajpayee Indian Institute of Information Technology and Management, Gwalior, and BITS Pilani. His primary area of interest is swarm intelligence and nature-inspired optimization techniques. Recently, he proposed a fusion social structure-based optimization algorithm, spider monkey optimization SMO, which is being applied to various problems from engineering domains. He has published more than 70 research papers in various international journals and conferences. He has worked with Indian Air Force and Liverpool Hope University UK for various research projects. He is the editor-in-chief of the journal Methods X, published by Elsevier. He is the series editor of the book Series Algorithms for Intelligent Systems AIS and Studies in Autonomic, Data-Driven and Industrial Computing SADIC, published by the Springer. He is the editor-in-chief of International Journal of Swarm Intelligence, published by InterScience. He is also the associate editor of IEEE Access, published by IEEE, and Array, published by the Elsevier. He is the General Secretary of Soap Computing Research Society, SCRS. He has also received gold medal at UGM PG level. Sir, we welcome you in our FDP, which is on the bio-inspired algorithms and optimization techniques for emerging research areas in computer applications.
Thank you very much, sir. I hope I'm clearly audible.
Yes, sir.
Yeah. Thank you so much for this opportunity from the NSUT, and it's really good to speak in a workshop on the bio-inspired computing, which is my I'm a student of this subject. So I hope just for my information, before this, the lectures are already, from yesterday, the workshop has been started. So certain lectures has already been done. So I request participants, if I'm repeating something, if there is anything overlap, just let me know so that I can escape and can move forward. In this today's lecture, I'm majorly going to introduce the subject bio-inspired computing, not going to concentrate only one algorithm, but in general, what is the subject, what kind of algorithms are there, what are the possible application areas of this subject, and what are the success stories that are already because of this bio-inspired computing. Uh, it will be good if participants can switch on their video, participants also switch on their video, and you can make the session interactive also. Means I don't mind if you in between also you send your questions or you ask your questions. Just unmute and you can ask the questions. There is no need to wait for the end. Okay, let me just share my screen. So I hope it is visible, right? My screen is visible. Actually, these bio-inspired algorithms or bio-inspired computing, right? Bio-inspired means the natural phenomena or from nature or from biological phenomena, the algorithms or some computing methodologies are inspired, which are a class of algorithms, class of computing techniques that are put into this category. Actually, what happens, you have the computing methods or the computational methods, uh, those are derived mathematically, which has certain mathematical background. But sometimes what happens, uh, the mathematically driven algorithms or mathematically driven or logically driven methods are not applicable to the problems of real world. There are many real world problems which are so complicated, so complex, that these algorithms cannot be categorized uh, based on these mathematically driven methods. And at that time, we need to take help of the nature. We need to take help of the biology, by which we uh, make ourselves better. We, the humans, make ourselves better. The birds, monkeys, any living being, living creature on this earth make themselves better. You know, the medical science has been developed quite good. Still, it cannot explain explain completely the function of the human brain, how the human brain is working. You cannot predict my next uh, with 100%. In deterministic way, you cannot predict my next statement. You cannot predict my next action, because my brain is only my brain. Your brain is only your brain. I was just thinking of if the people are interested to open their switch on their videos, that will be better. It looks like just I'm speaking from to a wall. Usually, just for a good motivation, if there are participants who switch on their videos, will be better. Of course, not compulsory, but it will be better. Okay. So human brain cannot be explained completely. Still, there is a possibility that human brain works. The humans are making themselves better. Humans are progressing, making robots. So many autonomous devices the human brain is making, but the complete explanation of human brain is not possible. So is it possible the scientists thought that is it possible that whatever the human brain works, the way in which human brain works, no matter we understand it completely or not, but the way in which human brain works, can we mimic this working of this human brain, and can we make a software or can we make a machine which is mimicking the human brain? This is called the bio-inspired computing. You are getting inspiration from the biological phenomena or natural phenomena, or from the brain, maybe the human brain, maybe the birds flocking, maybe the foraging behavior of some social animals, and so on, and making a software, making a computer program according to their inspiration. You cannot understand them completely, how they are working, but whatever they are doing, just you are making an algorithm based on their behavior, and your algorithm is also working intelligently. You know, the human brain is working intelligently, but you do not know how it is working. But you do not know how it is working, no problem. Whatever the human brain is doing, let us do the same thing with this computer program, and you may be able to get the similar kind of results from that your computer program. What I want to say to you, that in bio-inspired computing, you take the inspiration from some biological phenomena or some natural phenomena and develop an algorithm without understanding the mathematics behind their behavior. So this is bio-inspired computing. Let me just tell you in a statement by, okay, before I move forward, just before a month, I was reading this book by Yuval Noah Harari. He's considered, this man, this is a TED talk of this man, Yuval Noah Harari. This man is considered as the most intelligent person, living most intelligent person. And he has written a very famous book. I think many of you must have read that book. I was reading that book, The Brief History of the Humankind, Sapiens, right? So this a part of his talk, TED talk, I copied, and I want to share this part with you. Just listen carefully what he says. Actually, he's saying that the uh, uh, bio-inspired computing, or I should say the social behavior of the humans, is actually the major reason how the humans are so much progressing. Why the dinosaurs is die out from the earth, but the ants are there. Ants are so small creature as compared to the dinosaurs. Dinosaurs were more powerful than the ants, but ants are still on the earth, and dinosaurs become extinct. So what is the reason behind it? And the reason is the cooperative behavior. Some biological phenomena is there inside the ants which was absent in the dinosaurs. And can we understand that biological phenomena? Can we understand that cooperative behavior among the ants, so that we can simulate that cooperative behavior of the ants to a computer program, and we can make a computer program which can solve our problems, by which the ants solve their problems. So let me just run this video. I have to switch on the mic. So I'm mute in my this device. I'm making my computer mute, and
सर कंप्यूटर को अनम्यूट कर दीजिए, वॉइस नहीं आ रही हम लोगों तक.
Sir, can't hear anything.
Excuse me, sir. There is no voice.
yes,
Or a chimpanzee.
yes,
But the truth is that on the individual level, I'm in.
okay, just a second. I think okay, I got my point. Actually, I'm using two devices. The audio video is from my this laptop, this Mac, and this is this machine. So let me stop just a second. Give me a minute. I'll do this. No worries. Give me a second.
Usually, we look for the different.
I think now you can hear.
Yeah, it's okay now.
Yeah.
To Oxford Street or into. Usually, we look for the different.
Each and every word of this Yuval Noah Harari is actually a gold mine. Listen carefully, and it actually motivates us to work in the field of bio-inspired computing or in the field of corporate collective intelligence. Listen carefully. Each and every word is actually, he may not be aware, this person may not be aware of this branch of computing, but actually what he's saying is about the bio-inspired computing.
Between us and all the other animals on the individual level. We want to believe, I want to believe, that there is something special about me, about my body, about my brain that makes me so superior to a dog or a pig or a chimpanzee. But the truth is that on the individual level, I'm embarrassingly similar to a chimpanzee.
So what you want to say that at individual level, myself and a chimpanzee are at individual level where they both are same, but since we all are behaving collectively, we live in a society, we the humans share our knowledge. For example, here in this workshop I'm giving a talk, and another workshop I'm attending a talk, I'm learning, I'm sharing my information, you are sharing whatever knowledge you have, and this way we are making ourselves better.
And if you take me and a chimpanzee and put us together on some lonely island and we had to struggle for survival to see who survives better, I would definitely place my bets on the chimpanzee, not on myself. And this is not something wrong with me personally. I guess if they took almost any one of you and placed you alone with a chimpanzee on some island, the chimpanzee would do much better. The real difference between humans and all other animals is not on the individual level, it's on the collective level.
Is on the collective level. The difference is on the collective level. Now see, what do you mean by
Humans
collective?
control the planet because they are the only animals that can cooperate both flexibly and in very large numbers.
Important thing is this cooperation is flexible. Whenever it is required to cooperate, we cooperate, and whenever it is required to compete, we the human beings compete also with each other. So the cooperation is very much flexible, and it is at very large level. The corona, this corona disease has proved that the entire world is actually connected. Entire world is connected. So we are cooperating at the world level. We are not cooperating at the NSUT level only or at this workshop participants level. We are actually cooperating at the world level without your knowing. Actually, you are cooperating with each and every person on this earth.
Now, there are other animals, like the social insects, the bees, the ants, that can cooperate in large numbers, but they don't do so flexibly. Their cooperation is very rigid. There is basically just one way in which a beehive can function. And if there is a new opportunity or a new danger, the bees...
So, actually here he is giving a hint that the cooperative behavior of the humans, the simulation of the cooperative behavior of humans is actually difficult, while the simulation of collective intelligence or the cooperative behavior of ants, bees, these kind of social creatures is relatively easy because they are cooperating at a very small level for a particular task only, for one objective, while we cooperate with different objectives. I cooperate with the academicians for a different purpose. I cooperate with my family members for different purpose. I cooperate with my friends for a different purpose. Actually, in my life, there are many different purposes, which makes me different type of cooperation with different individuals. But the ants, bees, monkeys, fish, birds, they are very simple creatures. Their only one objective is to get the food and to survive or to save themselves from the predators. So simulating their behavior is relatively easy as compared to the human beings. So you can see that in bio-inspired computing, most of the algorithms are actually inspired by the social animals other than the humans, because simulating humans behavior is actually very difficult, because it's very complex, and very flexible. Since it is very flexible cooperative behavior, but there may be one day when there will be a simulation, when there will be an algorithm based on the cooperative behavior of the humans. Once we will have that algorithm, we will have one of the best algorithm, because we the humans are one of the best creature on this earth. We are on the top of the food chain, so the algorithm will also be on the top of all the algorithms.
Not reinvent the social system overnight. They cannot, for example, execute the queen and establish a republic of bees or a communist dictatorship of worker bees. Other animals, like the social mammals, the wolves, the elephants, the dolphins, the chimpanzees, they can cooperate much more flexibly, but they do so only in small numbers, because cooperation among chimpanzees is based on intimate knowledge, one of the other. If I'm a chimpanzee and you're a chimpanzee and I want to cooperate with you, I need to know you personally. What kind of chimpanzee are you? Are you a nice chimpanzee? Are you an evil chimpanzee? Are you trustworthy? If I don't know you, how can I cooperate with you? The only animals that can combine the two abilities together and cooperate both flexibly and still do so in very large numbers is us, Homo sapiens. 1 versus 1, or even 10 versus 10, chimpanzees might be better than us. But if you pit 1,000...
Look, there's a very important statement that one human, one chimpanzee, the chimpanzee can better survive. 10 humans, 10 chimpanzees can better survive, then can better cooperate with each other. But just imagine next his statement, the 1 lakh humans and 1 lakh chimpanzees, then 1 lakh humans can better cooperate. Actually, this is our flexible cooperative behavior, that we can better cooperate in large numbers.
Humans against 1,000 chimpanzees, the humans will win easily, for the simple reason that 1,000 chimpanzees cannot cooperate at all. And if you now try to cram 100,000 chimpanzees into Oxford Street, or into Wembley Stadium, or Tiananmen Square, or the Vatican, you will get chaos, complete chaos. Just imagine Wembley Stadium with 100,000 chimpanzees. Complete madness. In contrast, humans normally gather there in tens of thousands, and what we get is not chaos usually. What we get is extremely sophisticated and effective networks of cooperation. All the huge achievements of humankind throughout history, whether it's building the pyramids or flying to the moon, have been based not on individual abilities, but on this ability to cooperate flexibly in large numbers.
Actually, whatever the progress we the human beings have done is actually based because of our cooperative behavior, because of the collective intelligence. Actually, it is all because of our collective intelligence. This collective intelligence, since we have done the progress based on this collective intelligence, is it possible that these kind of collective intelligence or these kind of biological phenomena by which other animals are surviving on this earth, can we simulate that behavior in a computer program? And if yes, if it is possible, then that computer program will be an autonomous system, will be an intelligent computer program, which may not require the external input to solve the problems. My teachers taught me till PG class, right? I have a question answer system up to PG class. UG, PG teachers teach like this is a question and this is an answer. But when I took the admission in PhD, my teacher gave me the question, or sometimes not even a question, right? You find the question, you find the answer, only the question. So based on my previous understanding, based on my all the training which were given, now since I'm an autonomous system after getting my PG in the subject, autonomous system, intelligent in that particular subject. So for this question, now I will give, based on analyzing all the information which I obtained till the PG class, I will give the answer of this new question. So is it possible that similar kind of system we can develop for a computer? Means I train the computer for the given input and output for the question and answer. Then can I pose a new question to the computer that I do not know, you do not know the answer of this question. Can you give me the answer of this question based on those question and answers? Based on those question and answer means you are teaching a computer till PG, and then you are giving a problem of PhD to a computer and then asking that write the thesis. Actually, this computer program in bio-inspired computing, you are doing the same thing. You are doing the same thing. Let me come to the, okay, just a second here. So what I'm going to speak today, what is the bio-inspired computing formally, just, and then actually bio-inspired computing is nothing in more sophisticated technical terms, it is called the computational intelligence. It is called the computational intelligence. I'll come to why it is called. And then I will, since I'm particularly out of these bio-inspired computing, I'm a student of swarm intelligence. So I'll define the swarm intelligence. I will also define the evolutionary computation. I will also define this. And then I will give some basic idea of all these algorithms, that how they work. Of course, not possible to explain all the algorithms one by one, but I can give you the links or the resources from where you can learn these algorithms. And then I'll share some success stories of these algorithms. So if you ask me the bio-inspired computing, then it's very simple. It's the name itself suggests you that it is a biological inspired approach to creating softwares. This is the approach which is inspired from the biology, not from the mathematics. Remember, if you are solving a problem using Newton-Raphson method, suppose the Newton-Raphson method, then there is some mathematics behind it, behind this formula, that x equal to x minus fx by f dash x. So behind this formula there is some mathematics. But if I write the other formula, x equal to suppose x plus h, right, this formula, and this h here in this time, this h is your minus fx by f dash x, right? I hope you minus fx by f dash x in this Newton-Raphson formula. But if this h, instead of deriving from some mathematical formula, there are a Taylor series, Taylor series, through Taylor series approximation, termination of Taylor series up to a certain number of terms, you obtain this formula of h. What if this h is not obtained from some mathematics? It's obtained from some biological phenomena, some natural phenomena, some behavior in the nature, some special intelligent kind of behavior in the nature, right? If this h is obtained, then whatever the method you are developing is called the bio-inspired methods, bio-inspired algorithm. So actually you are creating some intelligent software, you are creating some intelligent computer program which are actually based on the biological phenomena, not based on some logic, or not based on some mathematics. If you will ask me the mathematical background behind the genetic algorithms or particle swarm optimization, I may not be able to tell you. I may not be able to prove mathematically that why these algorithms are actually working, right? So bio-inspired computing represents the umbrella of different kind of studies which consists of computer science, mathematics, and biology, right? So of course you need to understand some basic concepts of biology also to simulate them into a computer program. And of course when you want to simulate the biological phenomena to a computer program, you will require some mathematical understanding also, that how to write this equation, how to write this formula of H for this particular phenomena, So of course, some mathematics background is required, but this mathematics is not that advanced kind of mathematics. If you are an engineer, it is more than sufficient. In fact, 12th class mathematics is more than sufficient for this. So bio-inspired computing optimization algorithms, basically most of the time these algorithms are for optimization purpose, is an emerging approach which is based on the principle and inspiration of the biological evolution of nature to develop new and robust computing techniques. Actually, robust computing techniques, what I said, if you will apply this Newton-Raphson method to a problem which is non-differentiable, if the function is not differentiable, suppose you want to apply the Newton-Raphson method to the given problem, and the function is not differentiable, then of course you cannot apply, because you require a derivative of the function, right? So function need to be differentiable to be applied to apply this method, Newton-Raphson method. But actually, what happens for the real world problems, your problem may not be differentiable, your function may not be differentiable, even your function may not be continuous, even your function may not be convex, quasi-convex. Actually, all the optimization algorithms, traditional optimization algorithms, or the mathematical optimization methods require a lot of mathematical conditions to be satisfied before they apply to a problem. And when you are dealing with a real optimization problem, real world optimization problem, true problem, then rarely these properties are satisfied. Suppose you want to decide the optimum length of the platform for the Delhi Metro. Next 100 years, in next 100 years, up to 100 years, you want to run this Delhi Metro, right? No change, no more civil work will be required, so that we should plan it in advance. Now, what should be the platform length? What should be the platform length so that it can serve, this Delhi Metro can serve the purpose for next 100 years, right? Right now, if you will make it 2 kilometers long, it will be the waste of money, waste of maintenance. A lot of maintenance will be required, so it will be waste of maintenance. If you will make it 100 meter, 200 meter, then it may be exhausted in next 10 years, because as the population grows, more and more people are coming to Delhi. They start commuting, petrol diesel price increases, so they start commuting using Delhi Metro. More coaches will be required, so of course after 25 years, 10 years, more length of the platform may be required. So what should be the optimal length of the platform so that Delhi Metro can serve the purpose for 100 years? Solving this problem requires a lot of information, by which rate the population will grow in the country, by which rate the population in Delhi will grow, by which rate the commuters of the Delhi Metro will grow, and accordingly you need to plan this platform size, length of this platform. Actually, when you will model this problem, the problem will be so difficult that you may not be able to analyze whether your modeled problem is continuous or convex or differentiable or not. Sometimes, your objective functions become so complicated that you cannot analyze them mathematically. And at that case, you may not be able to apply mathematical methods. In that case, you are left with no choice other than the bio-inspired computing. So bio-inspired computing is actually the requirement of the time. You cannot solve the problems of the real world without bio-inspired computing. Of course, when I say that when the traditional methods fails, you come to the bio-inspired computing, and I say that bio-inspired computing has the choice, is the one choice. So this one choice is not like a Brahmastra. It is not a Brahmastra. Means if I say that when they cannot solve, these algorithms can solve. Yes, these algorithms solve subject to. There is a limitation of these methods. There is a limitation of these methods. Limitation is that these are probabilistic methods. These are probabilistic methods. What does it mean? The answer is given probabilistically. When you apply the Newton-Raphson method, when you apply the simplex method, when you apply the Fibonacci search method, golden section search method, you know, deterministic methods. When you will apply to solve a problem, you will always be determined. Deterministically you can say that in this much time, by this method, you can obtain only this solution. This is the best solution that this method can give in these. Nobody can find better than this solution. Also, about these methods, these are called deterministic methods. Deterministic methods, and the methods those are inspired from the biology are called the probabilistic methods. Probabilistic method. When a child took birth, nobody can say that he will become the prime minister or a waiter in the restaurant. Nobody can say. Nobody can say deterministically that he will become a waiter or a prime minister. Means there is a probability that a child can become a prime minister, a child can become a waiter. Waiter means I just want to say that what it will become, there is a probability. Nobody can say deterministically that the king's son will become the king. Biology is not deterministic, right? So of course the methods which are inspired from the biology, how can they be deterministic? They are also probabilistic. So whenever I apply a method which is inspired from the biology to a problem, the answers are given probabilistically. Means whatever the answer I'm giving you is the best available answer, but one can find better than that. If a child born in a family grown to be a chief minister, and he become, the parents become very happy that, oh, my son become the chief minister, so good post. Actually, he cannot say that the son cannot become the prime minister. He can become the prime minister also. This is the best available they have given to that child. So what I want to say, if I say that this is the solution, this is the function value, I am giving you the best available answer from this algorithm, but one can find better than this answer. I will never be able to say you that this is the deterministic answer, this is the final answer, nobody can find better than this answer. I will not be able to tell you that this is the true solution. I will not be able to tell you that this is the true solution or true optima. We always say that it is near optimal solution. It is near optimal solution. So there is a new word for these bio-inspired computing. I always say that this is a near optimal solution. It is close to near optimal solution. Now, how close it is, don't know. I cannot prove this, right? This is a drawback of these algorithms. Of course, no free lunch theorem. You may have heard of this. Mackard and Walpole were the two scientists who gave this concept of no free lunch theorem, which is actually based on the Bible's statement that nothing comes free. Nothing comes free. If you have a set of algorithms, if you have a class of algorithms which can solve the problems with no mathematical conditions to be satisfied, your problem is not satisfying any mathematical condition, and still you are able to solve a problem, then of course there will be some cost, and the cost is deterministic nature. You are giving the answer in probabilistic nature. There is a probability. You will say that, okay, 99.9999% 99 I think if I say probability, then I should write like this. This is the probability, or this is the percentage of chance that this is the probability that this answer is optimal solution, but I cannot say completely. The probability will never be one. So the drawback is your answers are given in probabilistic way, not in deterministic way. Profit is, merit is that you are able to solve almost all kind of optimization problems. There was a famous statement by the Euler, that Euler was a mathematician, great mathematician, who said once that, listen carefully, there is nothing in the world which cannot be thought of something of minimization or maximization. In the world, there is nothing, no problem. What you want to say, there in the world, there is no problem which cannot be modeled as an optimization problem, minimization or maximization. All the problems can be modeled as an optimization problem. And if you have an optimization problem, I want to add that one tag to this statement in the Euler's statement. there is nothing in the world which cannot be thought of something of minimization or maximization. And once you have this maximization or minimization problem, there is no problem which can be left unsolved if you have a bio-inspired optimization algorithms. So what actually, if you add this transitive relation, all the problems, optimization problem, all the optimization problems, bio-inspired algorithm, if you use the transitive relation with these two statements, then you can say that all the problems can be dealt with bio-inspired algorithms, with bio-inspired computing, right? So if you have a bio-inspired computing, at least you can try, you can solve that problem using bio-inspired computing, of course probabilistically, but at least you can give some answer. Other methods will not be able to even touch that problem. If you will touch a problem using Newton-Raphson method where the function is not differentiable, you are doing wrong. Answer will definitely be wrong. It will not be even near optimal. It will be a wrong solution. It may not be even the optima. But here, at least you are giving a near optimal solution. So whatever kind of problem you have, you can deal it with bio-inspired computing. So I hope now I have enough given the motivation to learn the bio-inspired computing. Okay, I hope you people are listening, because it's a wall, just a wall, and people are just behind the wall. So it's really very challenging for the speaker to speak to a wall. Okay, so the computational intelligence. Actually, in bio-inspired computing, you develop some computation, bio-inspired computing, you develop some computing methods, some computing methods. And these computing methods are actually the intelligent methods. These are actually the intelligent methods. And therefore, these methods are put in the category of computational intelligence. These methods are put in the category of computational intelligence. The intelligent software, intelligent programs, intelligent algorithms are made because of computing. And from where this computing is coming? From inspiration from the nature, inspiration from the biology, right? So actually, the better technical word for bio-inspired computing methods is actually the computational intelligence. Right? So before I move, just quickly I define this computational intelligence. What is the computational intelligence? It is the study of the design of intelligent agents. There is somebody, it is named as God, is designing us, the human beings or other creatures on the earth, right? So he is designing these intelligent agents on this earth. Can we behave like the God for the computer to create these kind of intelligent agents in our computer program? Yes. The way by which we create these kind of intelligent agents, similar to these kind of intelligent agents, to a computer program, this process is called the computational intelligence. So it is the study of the design of intelligent agents. In this computational intelligence, we design intelligent agents, right? We design intelligent agents. Now, of course, this computer is a finite state machine. Computer is a finite state machine, and the human brain is an infinite state machine, as per our understanding. Of course, for God, for that Uparwala, this human brain may be a finite state machine. For him, this may be a finite state machine, but since we do not understand it completely, so we call it infinite state machine, because infinite, the prediction is not possible. In computer, you can predict, because whatever you have programmed it works accordingly, right? So when we want to create intelligent agents to a computer program, we need to define it properly to this machine, because machine by itself will not understand anything, right? So we need to define, what do we mean by agent, what do we mean by intelligence, what do we mean by intelligence, and what do we mean by agent. Please bear with my handwriting. Actually, this pen nib is also not properly working. It is actually, it's a 2 years of online classes. So it's saying that change me. It's a, okay. So what I said, agent. So agent may be anything. You can work on robots. You may, it's a computer program. It may be a robot. It may be, and it may be this pen, this is stylus pen, or this may be a mobile. You know, this mobile. Let me just give you an example of this mobile. This is an intelligent mobile. Mobile is an intelligent device, or this is an intelligent agent. And how this is an intelligent agent? Actually, let me give you an example, that computational intelligence example. When I bought this mobile, my name is Jagdish, right? So when I bought this mobile, I typed JAG. It was not predicting Jagdish. It was not predicting Jagdish, right? After the use of a week or so, it started predicting. As soon as I typed JA, it started predicting Jagdish. How? Because lot of time I typed JAG, so I finished with the word Jagdish. The input data, output data, input, question, answer. I gave many times. I gave the question and answer. So next time it started predicting the word Jagdish. When you buy this mobile, the same company mobile, same model, same everything, same number of days. If your name is Jagannath, if you type JAG, it will predict Jagannath. But in my mobile, it will predict Jagdish. This is called the intelligence. I hope now you understand what do we mean by intelligent machines, intelligent robots, intelligent computer programs. There is an intelligent computer program in it, which is called the deep learning, which is actually the simulation of the human brain. So this mobile learns based on these kind of input output. So this is an intelligent machine, right? So this, now according to the situation, we need to define the intelligence according to the situation. If we want to make this mobile intelligent for this purpose, of course it is this intelligent for this purpose. But a self-driving car need to be made intelligent for some other purposes, right? So of course we will define intelligence accordingly to a self-driving car, to a drone, to a aeroplane, to a mobile, to a stylus pen, to a computer. The intelligence are defined in different way, right? Accordingly we define the algorithm, accordingly we design the algorithm for that purpose. Now in general, the intelligence is defined based on these 4 properties. All the computational intelligence algorithms or the bio-inspired computing algorithms should have these 4 properties. Without that, your bio-inspired computing or the computational intelligence based algorithm are no longer valid, right? Are no longer valid. They may work for a small problem, they may work to solve one problem, but in general you cannot regard them as an algorithm or computationally intelligent algorithm. The very first property is whatever it does is appropriate for its circumstances and its goals. An intelligent agent always do whatever is good for it. For example, I'm a professor, so I'm giving lectures, attending lectures is good for me, so I'm doing it. But I'm not attending a workshop on drama. I'm not attending a workshop on drama. I'm attending a workshop on computational intelligence, because I'm intelligent. I know what is good for me and what is bad for me. I'm a human being, living being, right? So intelligent person should have this property. The second property is it is flexible to changing environment and changing goals. You know, the intelligent person is always, there's a very flexible cooperative behavior we have, very flexible cooperative behavior we have. You know, if the environment changes, if the goal changes, we should be changing our cooperative behavior. For example, you people are academicians, researchers, professors. So I have a different kind of interaction with you. If there are a group of friends at my house, then I have a different type of interaction. Of course, I will not speak on computational intelligence with my friends. Of course, I will definitely not speak the way I speak to you or to my friends, to my family, right? The cooperative behavior is flexible according to the environment, right? It learns from experience. It learns from experience. The intelligent agent will learn from the experience. More the input, more, if I use the mobile for 1 day, it may not start predicting. 2 days, slightly. 3 days, 7 days, 1 month or so, then it will start predicting Jagdish. That most of the time, I finish the word with Jagdish, right? So it will predict Jagdish. It learns from the experience. More the input and output I gave, more the data I gave to the machine, and the machine become intelligent. Machine started learning. It makes appropriate choices. The intelligent agent should be able to distinguish, should be able to decide that if there are two directions to move from at particular point, then it should be able to define that, okay, this path is better for me. If there are two workshops going on simultaneously for one of you, and you are into computational intelligence, and in the same NSUT itself another workshop is going on chemistry, some subject on chemistry, and you are into computational intelligence and this workshop, of course you should have the choice to attend both. Entry is open to both. You will attend this because you know that is not good, right? So it makes, if more than one choices are available, suppose in computational intelligence, again, if Jagdish Bansal is speaking and the one great professor or some top scientist in this field is speaking same workshop, then you will be able to understand that, okay, if I will attend Jagdish Bansal's class, will not get enough. There's a top scientist in this area, will attend his class or will attend his lecture. So you should be intelligent agent can measure the betterment, that who is better, which direction is better for me. Intelligent can decide that. Actually, the bias-word algorithms, or these algorithms, are basically classified into three categories: swarm intelligence-based algorithms, evolutionary computation-based algorithm, artificial neural network-based algorithm. Actually, I'm a student of swarm intelligence. My major stress will be on this. Of course, I will speak on these two categories also. Okay. So let me, yeah. If I define this swarm intelligence, for the swarm intelligence, let me just play a 10-second video for you. Let me play a 10-second video for you, and let me ask from you that what you understand from this video, right? You tell me, just a second, let me share. And here it's the, no. Yeah, here it is. And let me share the screen. Can you see the screen there? I think so. Is it? Can you see the screen?
Yeah. Yes, sir.
Yeah. So just I wish that you people respond for this. I'm playing this 10-second video, and you tell me what special you observed in this video, right? Carefully see this. A very simple video, but just something special among these words. They behave very intelligently in just few seconds. So that's all. So let me play it again, and you tell me, and then you please unmute and tell me what special you observed in this. I hope you watched the video. Should I stop sharing now? Now you tell me what special you saw there. You can again, pin my this. You can again pin my this screen. Anybody want to share? something that what is special in this flocking of birds? That is actually the swarm intelligence, the basic definition of the swarm intelligence. They actually applied the swarm intelligence. I hope you people are there. No response. So, okay. So calculate position and move towards. Yes, this, but they are not calculating. They don't have mathematics. They have not attended any mathematics course actually. They are not graduate in mathematics. So they are very simple creatures. You know, simulating these kind of simple creatures' behavior is relatively easy. You know, let me tell you what special they did. You know, there were birds were here. Yeah, birds were here. Because of some sound or something, they started flying in different directions. Initially, in different directions, they started flying, right? Because at that time, just moving from here was necessary. And when they started flying in different directions, yes, very good. This Aryan mentioned it very correctly. Yes, very good. Initially, there were random movements. But when they share the information with each other, and how they share the information with each other, no, they are not calculating the distance. They don't have the inch tape or something, right? They are not calculating the distance between each other. They are not telling them each other that, oh, my friend, come this side. They don't have the names also. Right, that bird number 5, you come this side. No, they are just observing the others. Where the majority of the birds are moving, you must have observed that majority of the birds were moving this side. So the birds moving this side, they took the turn and they started flying in this direction. Means they see their neighbors, that where my other friends are going, and when most of the birds started flying in the right direction, all the birds started flying in the right direction, because they realized that this direction for flying is a better direction. So they started flying in that direction. This is actually the swarm intelligence, cooperative behavior, cooperation with each other, and then taking a decision. Cooperating with each other. Now this cooperation may be based on just observation, or maybe based on some calculation, which this observation is actually simulated in terms of calculation in a computer program. How to simulate this observation into a computer program is our challenge, right? Is our task, and that algorithm will be a one swarm intelligence based algorithm. I hope you are getting my point. Just observe the natural behavior, simulate that into some algorithm. You will have a new swarm intelligence based algorithm. So in general, of course, the swarm intelligence is present in the nature from the birth of the nature. In 1999, Bonabu defined this formally, that it is the emergent collective intelligence of the groups of simple agents. Swarm intelligence is the emergent, it's an emergent. Initially, they started flying in different directions, right? So the intelligence were not there. What is the intelligence? Because of the intelligence, they started flying in this direction. But this direction knowledge, the knowledge of this direction was not inherent. It was emerged. When it emerged, when everybody started trying in different directions, and all the directions were explored, and finally they decided that we need to move in this direction. So it is emerged intelligence when everybody try. When everybody try, in the initially Corona time, you remember that I was just shocked that there is a lockdown. It was first time in my lifetime. Actually, we, the generation, never seen such kind of lockdown or something. So we just observe how the world will go. How the supply will be there, how the people go for the job and all. We were just shocked to see that, oh, this kind of lockdown, how we will survive. But very soon, I think within a month or so, the intelligence emerged among the human beings. And what is the intelligence? That everybody, the oldest faculty member in my university, started using these Zoom and Google Meet and all. They started initially. I'm using this Google Classroom from last 6-7 years, right? 6-7 years I'm using, and no, actually I presented to my department also that you should also use and keep the records online in software. I have no records offline. My Almira is always blank for the copies, and I never keep them, always online, right? I take exams online and all. Initially nobody, because everybody was smooth by going on, so intelligence was not immersed, but out of the necessity, because of this necessity, everybody started using these online classrooms and this Google Meet and all, and now everybody is comfortable. So this intelligence emerged because of the same objective, that we have to survive in this situation. This is called the swarm intelligence, that somebody has developed the Google Meet, somebody has developed this Zoom and all these softwares they have developed, right? And we started using, because this is called the emergent, and this intelligence is also collective intelligence. Still I cannot use Google Meet if Sundar Pichai stopped that giving the services of the Google Meet, right? If the Google stopped giving the services of Google Meet, I will be stopped. I know the software doesn't mean that I can use everything. So it's still the humans are surviving because of collective behavior. So it's a collective intelligence in a group. Let me tell you that thousands of these swarm intelligence based algorithms are available. Not hundreds, thousands of these intelligence-based algorithms are available these days. Actually, in 1992, when this ant colony optimization algorithm was introduced, at that time people started to think that, oh, this swarm intelligence is a very powerful tool for the optimization or for the computational intelligence. It's a very powerful tool. And at that time, this Marco Dorigo, one Italian scientist, in 1992, he developed this ant colony optimization algorithm. And actually, initially, he developed it for robotic path planning problem, traveling salesman problem, actually. So that is modeled as a traveling salesman problem, but it was actually for robot path planning, right? How the robot will move from one point to another point by avoiding the obstacles in minimum path, passing through the minimum path. So for that purpose, he developed this ant colony optimization algorithm. After that, many variations of ant colony optimization algorithm came, and it became one of the most famous algorithm in the field of swarm intelligence. In 1995, this algorithm was proposed, particle swarm optimization, by two US people, James Kennedy and Russell Everhart. So they proposed this algorithm, and now, based on the birds flocking behavior, for continuous. It was for the discrete optimization. This robot path planning problem is a discrete optimization problem, and this is a continuous optimization problem. So for continuous optimization problem, they proposed this particle swarm optimization. Let me tell you, there was a report of industry published in 2018. In 2018, this industry usage, the report's name, I don't know the report's name actually, but it is from the industry group of industries, world group of industries. They published this report, and they mentioned that in this report, they mentioned that 80% of swarm intelligence in the industry is either PSO or ACO, is either particle swarm optimization or ant colony optimization. Means if you know the ant colony optimization and particle swarm optimization, these two algorithms, you know the 80% usage of swarm intelligence in the industry. And in remaining 20%, all other algorithms exist actually. Why it is so? Because these two algorithms were initial algorithms. This doesn't mean that they are the best algorithms. All other algorithms are inferior than these algorithms. No. Even the better algorithms are available. Much better algorithms are available now. But these algorithms were initially introduced and initially industry adopted them. And now, of course, industry will not immediately change. Every day industry can't change the algorithms. In every day, 10 or 15 new swarm intelligence based algorithms are being introduced by the researchers throughout the world, and industry can't adopt them so quickly. So industry will take time, of course it will take time, but these algorithms are still very, very effective, very, very efficient. Artificial bee colony algorithm was introduced then in 2008, and spider monkey optimization algorithm is the one introduced in 2014 by myself, my two PhD students, and one researcher from the France, Maurice Clark, who was actually the pioneer researcher in the field of particles optimization. Maurice Clark did the pioneer research in this algorithm, so he is also one inventor in this algorithm. So we 4 people introduced this in 2014. Of course, it is not as popular as PS or ACO, but it is still quite popular among the swarm intelligence users and the researchers. And throughout the world, people are using this algorithm for their purposes, for their applications and different purposes. Okay. Another category of, okay, let me just quickly share another video on swarm intelligence, which will actually exhibit you the properties of the swarm intelligence. Before I come to this evolutionary computation, let me just quickly tell you around 1 minute or so video. Let me share the screen again, this screen, and here is the video. I request everybody to see this carefully. It is good to understand things. This. I hope this is visible. This screen is visible now.
Yes.
Okay. So listen, I'll keep on pause, and will explain if such a requirement will be there. But this video, it is a 4-minute video. I'll stop much before that, 3 minutes. After 3 minutes, I'll stop this. So this 3-minute video is actually explaining all the basic properties of the swarm intelligence completely, and it's a very interactive video. See carefully. I have not made this video. I took it from the YouTube. So that's a disclaimer. So social insects like ants, birds, fish, bees, monkeys, grey wolves, elephants, they exhibit actually a very, very special kind of intelligent behavior that is called the swarm intelligent behavior. And this swarm intelligence behavior has certain properties which are explained here. So this video is to understand the swarm intelligence properties. See carefully. So you can see here that there's some object is there, and all these ants are actually offering their services autonomously. They are offering their services. One ant is supporting from the lower side, one ant is supporting from the top side, and one ant see that there is a requirement, so it came immediately to help them to support from this lower side, from where it is going down. The members of the swarm, this swarm means the group of members. So the members of the swarm are giving their services autonomous way. Nobody is controlling them, nobody is guiding them, nobody is the supervisor. There is not a supervisor ant who is giving the instruction that you be here, you be here. No, it is a decentralized system, self-organized system. It is a decentralized, there is no center, no supervisor. It is a self-organized system. So swarm intelligence is actually a decentralized, self-organized system. This is a very important property, that it is a self-organized system. No leader, no central control. So in this self-organized system, each member autonomously offers its ability that I can do this, let me help you in this way. For example, in this COVID also, we the human beings are on the top of the swarm intelligence. Actually, we are the best as this Yuval Noah Harari in his TED talk mentioned, that the humans are the best individuals, best social creatures on this earth who offers this swarm intelligence. We are on the top, right? So because of this COVID, we offers, doctors were doing their job because everybody is aware of that humanity will not survive if we will not offer our services. Whatever, the teachers were doing their job, scientists started researching on the vaccine and medicine, and everybody was offering their services, right? Because there may be competition after everything gets over, then there may be a competition among us that, okay, I need this position, I need this much money, I need this land. There may be a competition, but when the question of survival occurs, then we cooperate with each other, right? So of course, because of the requirement. So the way which these ants are cooperating with each other, the way in which these ants are cooperating with each other, how they are offering their services, how they are coming each other, what they see, what they observe, right? Can this phenomena be applied to a computer and robotics? Yes, it can be applied. So such algorithms by which these ants are working, algorithms can be applied to computers and robotics. So we can also make such kind of autonomous computer program which solves the problem autonomously. No external input is required. All this behavior is now simulated using these four robots, right? So these four robots, the problem is to balance a platform. The problem is to balance a platform which is on one line, to find the optimal position by each robot so that the platform get balanced. See carefully. So before that is applied, we are going to define certain rules which are actually exhibiting the rules which the ants are following. So of course, we need to define certain rules by which ants are following so that we can implement those rules in the computer program to make that intelligent. See the rules. Each ant is aware of its surroundings. I mentioned in that property also that it should be able to find out the choices, that if there are two choices available, that Jagdish Bansal is speaking or some stalwart in the bioinspired computing is speaking, whose lecture is to be attended. So of course you can understand that stalwart lecture will be better, right? So you can measure the fitness of each path. Each ant is aware of its surroundings, that if I will remain here, I will be better, or if I will join them, I will be better, right? So they are aware of this. So this robot is finding the optimal position, optimal location where it should stay so that the platform is balanced. So you see, it is moving and the platform is balanced. Now it is stopped. Now the environment changed. Now if the environment is changed, it is flexible. I told you in those properties that it is flexible of the changing of the environment. If the environment change, goal change the position, right? So if the environment, now the environment changed because of this this object, it is changing its position to balance. Now to balance this, it has changed the position. I already mentioned about that members self-coordinate without a dictator. This rule I already mentioned. It's a self-organized system with no central control or no leader. Members cooperate in solidarity. Every member cooperate. Every member is active and dynamic. Remember, this is the necessary condition in the swarm intelligence, that every member need to be active and dynamic. I cannot sit idle. I cannot just eat and sit idle at my home. Nobody will feed me, right? Even my mother will tell, go and earn something. After 1 or 2 days, everybody can bear, but after some day, the members in the swarm cannot survive without working. So every member have to cooperate with each other, right? You see again the environment change. Now the 2 robots are there, and this robot can also move. So they are finding their optimal location. So, and they are cooperating with each other. They are cooperating with each other so that they can manage, they can balance the. You see, they found the optimal location. Now again, all 3 are cooperating, and they found the optimal location. Okay, so let's come back to the same. Now please pin this screen, the previous screen. So the swarm intelligence has certain properties, certain rules, out of which these 2 rules are necessary and sufficient condition. Means if and only if rule means if swarm intelligence is there, then self-organization. I already mentioned, let me write fully. The first property is this self-organization. And the second property is division of labor. Division of labor. This is division of labor, second property. So if swarm intelligence behavior is there, then these 2 property will be satisfied automatically, of course. And if these 2 properties are there in a group, then definitely you will have the swarm intelligence, right? So what you require, that these 2 properties should be satisfied. Self-organization, I already told you. Division of labor, I hope you understood from this video that division of labor means everybody divided their job. Okay, I have to work from this side, I have to work from this side, so that ultimately the objective is fulfilled, right? Self-organization and division of labor are the 2 necessary and sufficient conditions for this. How can we prove which algorithm is better and why? Who asked this question? And definitely I'll answer this question, but this question will be answered at the end, right? Because let me introduce some algorithm, then I will answer this question. Good question, but I'll answer this. Definitely I'll answer this. If I'll forget, please remind me. The next category of the bio-inspired computing is the evolutionary computation. Look, in the human society, just I'm giving an example of a human society. We are not only, it happens with every social society, right? Every social group, it happens. Whether it is fish, birds, lion, grey wolves, monkeys, whatever it is, it happens in their society also. Let me give you the example of the human society. We, the humans, not only cooperate, we compete also. right? Just imagine there is a position of a professor in computer science department of NSUT, Netaji Suhas University of Technology. There is a position of professor in computer science, one position of professor, right? And there are 10 applicants, right? Then these 10 applicants, but because of this swarm intelligence, because of the cooperative behavior, what we do, we improve ourselves, we make ourselves better. I know one topic, you know one topic, I'm attending your workshop, you are attending my workshop, and now we both know both the topics. We become intelligent, right? We know less. After cooperation, we become more, we become intelligent. I hope I'm correct on this. We not only become better because of the cooperation, we also become better because of the competition. And when the competitive behavior of the individuals in a group, when the competitive behavior of individuals in a group is modeled, is simulated in a computer program, then that branch of bio-inspired computing is called the evolutionary computation, evolutionary algorithms, right? Now, let me give you an example of the professor position. 10 applicants are there. If the 10 applicants are there, then what will be 1 month's notice of the interview? Everybody will be working very hard. Let me revise my thesis, let me revise my research papers, let me revise my teaching subjects, let me revise my general concepts, let me revise the subjects, let me think, let me check the NSUT website, what the subjects they are teaching, right? How we prepare for the interview, right? So they may ask, and let me check what is their core area of research. So we will prepare ourselves, we will make ourselves better in this 1 month. We will not leave any stone unturned. If we want, of course, if we want the job, that is the objective, right? Of course, we want to reach at the objective. We want to reach at the optimal solution. Getting job is the optimal solution location, right? So we will leave no stone unturned. We'll do our best to make ourselves better for the interview, right? Because of the competition. Just imagine another situation. All the 10 people will do their best, right? Another situation, there are 2 positions and 2 applicants, or 1 position and 1 applicant. Just think of a very simple situation. 1 applicant and 1 post. Then if there is a position of professor, I'm the applicant and I want that job. I know that I'm the only one applicant and they have to take me. They require a person and I'm the only applicant. There is no second applicant for the position. Then will I prepare so desperately for the interview? No, I'll not make myself better because there is no competition. If the competition is there, then only I will make myself better. So the individuals become better, not only from the cooperation, but the competition also, right? So in that case, the humans compete with each other. Humans in a group, the humans compete with each other. They will not cooperate. I will not give my strategy to my opponent who is also appearing for the interview, right? I will not share my strategy that which subjects I'm preparing, how I'm preparing, and what is my expectation that what type of questions they can ask. Strategy I can share with others, but not with other competitors, because the post is 1. If the posts are 2, then of course I can share. Try to understand, when the natures of biology's competitive behaviors are simulated in computer program, then it is called the evolutionary computation. In evolutionary computation, again, there are many algorithms, right? I hope you understand. There is a basic difference in the swarm intelligence and the evolutionary computation. In swarm intelligence, cooperation there. Swarm intelligence algorithms are based on the cooperation among a group, among the members in a group. Cooperation-based algorithms are based on the competition among the members in a group. So competition versus cooperation. These algorithms are actually based on the competition, and those were based on the cooperation. Of course, members become better because of the competition also. Now, this competition is based on certain rules. This competition is also based on certain rules. These rules, or these situations are called the operators, and they are reproduction, mutation, recombination, natural selection. I'm coming to this, right? I'm coming to detail of this, but I hope now you understand many, in around 2000 or even around 2004 or 5, up to around 2004 or 5, people used to call SWAMP PSO is an evolutionary algorithm. PSO is an evolutionary algorithm. People used to call this because initially in 60s, genetic algorithm was introduced. Genetic algorithm was introduced, and it was an evolutionary algorithm, and it was a population-based algorithm. It was a population-based algorithm. So due to that population-based, and these PSO was also a population-based algorithm. So just everybody, it had a similar kind of structure, but they forgot the one basic nature, that it's a competition, it's a cooperation, right? So I can't call PSO an evolutionary. It's a technically wrong thing. Not evolutionary algorithm. Evolution means because of the competition. Because of this competition, the evolution happens, right? Because of this competition, or because of the survival of the fittest. Darwinism principle, this evolution happens. But here there is no, in the swarm intelligence, there is no survival of the fittest. Everybody will survive. Here everybody survives. But in the evolutionary competitions, weaker will die out. Weaker members will die out. Actually, what happens? There is a population. There is a population of members in the evolutionary competition. There is a population of members. First of all, there is a selection. Suppose there are two members which are selected for the reproduction. They are selected for the reproduction, and they do the crossover. They do crossover between them, and then they generate two offsprings, two children. They generate two children. Now there were two parents and two offspring. Now the population becomes double. Everybody will do this kind of selection. These two members got selected, and they produces two offspring. Now the population become double, but the double population cannot survive in the same location. So 50% have to die. Now there is a competition among these four. Now there is a competition among these four people. Competition among these four. And that competition will make sure that only the fittest will survive. Survival of the fittest. Only the fittest will survive. So maybe the X1 is the best and Y2 is the second best. So X1 and Y2 will survive, and these two will die out. This is called the survival of the fittest, Darwinism principle. All the evolutionary computation-based algorithms are actually based on the Darwinism principle, survival of the fittest. Okay. There are again many algorithms in this category. Genetic algorithm is the one most famous, important, and efficient and very good algorithm in this category. Many variants have been introduced of this category, genetic algorithms category. It's multi-objective variant, binary. Of course, initial version was binary, right? Remember, its initial version was actually the binary genetic algorithm. The coding was in binary coding. Now real coded genetic algorithm is there, multi-objective genetic algorithm is there, constraint genetic algorithm. Lot of variants are available of genetic algorithms. You must have heard of this algorithm. Evolutionary strategy, evolutionary program, cultural algorithm, genetic programming. These are algorithms similar to the genetic algorithms. This differential evolution is one of my favorite algorithm. One very simple algorithm. It is not directly based on some natural phenomena or biological phenomena, but it is using the crossover operator and the mutation operator, and therefore these two operators are actually the evolutionary operators, and therefore I put this algorithm in this category. But if you ask me, it's a correct classification? No, it's not a correct classification. Differential evolution is not completely an evolutionary algorithm, because in evolutionary algorithm, what happens? First of all, crossover happens, means parents generate offsprings, and then the best will survive. Best two will survive. Best will survive, and then among these best, there is a mutation. Mutation means the small change. Mutation happens. So the rule of evolutionary operators is crossover and then the mutation. But in differential evolution, what happens? there is a mutation and then the crossover. Means only one parent is there. Offsprings are generated, only one offspring is generated in differential evolution. Offspring is generated based on the mutated another parent. One parent, and then mutate this, it will become the another parent, right? So these two will make the crossover and then will generate the next offspring. I hope you understand. Mutation comes first and then the crossover. So this algorithm, deviate from the evolutionary algorithm in this way, but since it is using crossover and mutation, so I put this in this category because there is no different category for this algorithm. Biogeography based optimization is a very, very recent addition in this category. I think in 2015, I think it was in 2015. It was introduced by one, I just forgot the year, one Dan Simon, US scientist. He's in my editorial board also, in my journal's editorial board also, Dan Simon. So he's a very, this is one very novel kind of algorithm, biogeography based optimization, which is based on the migration of species from one island to another island. How the species migrate from one island to another island. Okay. I know the time is going to up, so I just spider monkey optimization is inspired by the foraging behavior of spider monkeys, right? Particles optimization I mentioned. Artificial bee colony algorithm is inspired by the foraging behavior of honeybees. Okay, ant colony optimization I already told you, they always find the shortest path from one point to another point. Biogeography based optimization I already mentioned. Genetic algorithm. Before I finish, I want to share some success stories, then I'll take the questions. Right, so just quickly, let me share another 10-second video. Can you see the slide? Can you see the screen now? Just, it's a, see, you can see that there is a group of drones. They are flying autonomously. Let me. You see the group of drones are flying autonomously, like group of birds, and nobody is controlling them. They are deciding their path autonomously by themselves, looking at the environment, like those birds on the tree. They decided their path. Similarly, these drones are deciding their path. It is a drone swarm. This concept is called the drone swarm, and let me tell you, really, it's very, very latest technology. I'm also working in this area, and of course for Government of India we are working. And if anybody of you are interested in this area, very, very emerging topic, you can refer this research paper. I found this one very good research paper which explains it exhaustively, this subject, this research paper. Optimized flocking of autonomous drones in confinement environments. Okay, another success story which I want to share is this. This first train. This first train is the Shinkansen N700 bullet train. You must have heard the very famous name bullet train of Japan, right? You can see this aerodynamic shape of nose shape design of this aerodynamic shape, this part. So this part was designed with genetic algorithm. Let me tell you, it was genetic algorithm by which it was designed. And Japan Railway was very, humble for this discovery, that they mentioned categorically this statement on their website. Right now it is not in their website, of course, that the genetic algorithm gave us this solution. And let me tell you, this is the best available solution till now, right? No algorithm could found better solution than that. genetic algorithm is also being used in the designing the aerodynamic shape of the aeroplane wings, the wind turbine blades. These kind of aerodynamic shape designs are being developed based on the genetic algorithms. Best algorithm for that purpose. Into railways, I found that design, of course, I gave one example: scheduling, allocation, fault diagnosis, autonomous, predictive fault diagnosis. For those purposes, we can think of these kind of algorithms. Okay. I solved this problem 2 years before using biogeography based optimization algorithm, finding optimal location of wind turbines in a wind farm. When the wind turbines are situated, the one wind turbine has the impact on other wind turbine. This impact is called the wake effect. This effect is called the wake effect, which reduces the efficiency of the other wind turbine. So if they are not properly located subject to each other, the total energy output from the wind turbine reduces. And therefore, finding the optimal location of those wind turbines in this wind farm is a challenging task. We modeled it as an optimization problem and solved using BBO. We got publication also, very good publication also. So what next? Next is no free lunch theorem, NFL. It says that no algorithm is perfect algorithm. Every time you have a choice for the development, for the betterment, you can always develop better algorithms. Nature has enough sources, biology has enough sources, biological phenomena are not fully understood by the human beings. So still you have enough inspirations for that purpose, and you can develop new and new algorithms for solving new and new problems. Because of this advent of computational efficiency, you are getting new and new problem every day. Before some time, this Facebook was not there. So after coming to Facebook, now you have a new problem arises. After having these digital photography, this mobile can take thousands of the photographs and no expense. But now there is a new problem, that how to classify the pictures, how to store my data of the Facebook, how to store these pictures and classify only important pictures to save, others want to delete, or my good pictures, mediocre pictures, bad pictures, or some interesting pictures, how to classify them. You have, and if you do it manually, of course you require it. Now everybody's mobile, I think they require at least 1 month to classify them. But so of course you got a new problem of this data analysis. Then of course you have a new algorithm you have to develop. You have to develop new algorithms. So always you have a challenge for developing new algorithm. Whatever thousands of the algorithms are developed are not sufficient. The research is open. Research is open because the problems are coming every day. The new and new problems are coming. So I always say that best AI is CI, and best CI out of CI means computational intelligence. Out of AI, best is CI. Best is out of best CIs. I work in SI, so I say that it is swarm intelligence. That's all from my side. Thank you. Thank you so much. Now I'm open to questions. If you have question, I'll be happy to answer.
Yes, sir. Am I audible, sir?
Yes. Yeah, Preeti ji, आपका question है that which
actually,
yeah, please.
Yes, sir. Actually, I have worked on PSO, Firefly algo, ABC algorithm, and actually I have Viva tomorrow also. So examiners always ask, what is the difference between these and why you have attempted these algos only? So what are the advantages of using it?
Okay, so you want me to answer that examiner's question?
Please, sir. Yes, sir. It will be very helpful.
Yes. Let me answer. First of all, let me give you one disheartening statement that there is no answer for this question. Right? Out of thousands of the algorithms, there is no logic I can give you that these 3 algorithms you should study. Whatever you have studied is correct. There is no problem at all. You have studied, as you said, you have studied PSO, Firefly algorithm, and ABC, right?
ABC and social group. Yes, sir.
Okay. So these algorithms are mostly for continuous optimization problem, but actually you need to justify that my concentration was for continuous optimization problem. So I took these algorithms, and let me tell you, Firefly algorithm, I'm not very convincing about this Firefly algorithm. Because there is some problem actually mathematically. I found some problem in this algorithm, so I'm not very much convinced, but it is working. But it is working. Let me tell you, it is working very good, this algorithm. ABC and PSO are one of the top algorithms for the continuous optimization. Just a second. Beta suno. Okay. My son wants to go somewhere, so. This PSO and ABC both are very good, one of the top best algorithms for the continuous optimization problem. So choosing these algorithms is a very good choice. But if you ask me that why not you have chosen the differential evolution, no answer. There is no answer that why I have chosen these algorithms. You have to choose 1 or 2 or 3 algorithms for your studies, of course, and then you analyze those algorithms and develop those algorithms, apply those algorithms for your purpose. Now, if you ask me what is the difference, let me explain you just quickly. I know that this is a long answer, but if this is the basically g minus x and x equal to x plus b. This is the equation in this PSO, and in ABC the same equation is like this. That's phi x minus xr, right? So this is the h. Actually, all 3 algorithms are based on this formula, where h is obtained based on this velocity vector, based on this, and based on the Levy flight. In Firefly algorithm, you are using the Levy flight, right? So based on the Levy flight, you are using this value of h. So you found one similarity in all these 3 algorithms, that all these 3 algorithms are actually based on these based on this, and h is calculated based on different behaviors, and all 3 algorithms are very good for the continuous optimization problem. So you took them. Difference, of course, all 3 algorithms are inspired from different natural phenomena, and they perform differently for different kind of problems. You can always show you hundreds of the research papers have been published where you can show that one paper can show that PSO is better than ABC for problem P1. Another problem you can show that ABC is better than PSO. Another problem you can show that Firefly algorithm is better than ABC, and so on. And another problem you can show that ABC is better than Firefly algorithm. So you can say that these different problems were there. So they were performing on different capacities on different type of problems. For my problem, this was my problem. So I have explored these algorithms, and these are my results based on that. And I found this relation. You must have found some relation that ABC or this kind of relation, that for my problem ABC is the best, then the PSO, then the Firefly, or the Firefly is best, then the PSO, and then the ABC, and so on, right? So you just say that I have, but you can never claim. These are probabilistic algorithms. How you can claim that whatever the results I have obtained from these 3 algorithms are the best? Nobody can find better results by any other algorithm. Yes, there may be some other algorithm which may be better than these algorithms, but you can't explore all possible algorithms on the earth, right? So you said that I have analyzed these 3 algorithms for researchers, for the future researchers. It will be an academic record. It will be a research record for the future researchers, that if you want to solve this problem, 3 out of these 3 algorithms, these are the results. If other algorithms, they have to explore. Other algorithms, they have to explore, right? So these questions are to ask only, just to understanding your depth of knowledge in this area. If you will say that these are the best algorithms and that's why I have chosen this, no, this is wrong answer. I have chosen because thousands of the algorithms are available. Out of those, these 3 algorithms I have chosen for my study. I found these results for this. These 3 algorithms are in this category. these three algorithms are of this category. Remember, genetic algorithm is not of this category. Remember this carefully.
Yes, sir.
Genetic algorithm is not of this category. I have not chosen this. So all these three algorithms are in this category, which are based on this. And I compared the results. That's all.
Thank you, sir. Thank you.
Thank you. Any other questions? So, and you can never say that one algorithm is better than the other for all possible problems. For your problem, this relation may be true, but for other problem, other relation may appear. Okay. So, any other question? If not, we can stop then.
Good evening, sir.
Chalo.
Hello, sir. Good evening. I have a question.
Yeah, please.
सर जैसे एल्गोरिथम में ऑप्टिमल चेक करने के लिए एक बड़ा पैरामीटर है कि एफिशिएंसी चेक करें, उसकी टाइम कॉम्प्लेक्सिटी चेक करें. एक पैरामीटर है कि स्पेस कॉम्प्लेक्सिटी हम देखें, एक पैरामीटर है कि उसकी एक्यूरेसी देखें कितनी है. इन तीन के अलावा कौन कौन से पैरामीटर हैं सर जो ऑप्टिमाइजेशन ऑफ एल्गोरिथम के लिए ज्यादा इंपॉर्टेंट होते हैं?
Actually, all these I'm not talking about all kind of optimization algorithm. Bio-inspired optimization algorithm, if you will ask me, three major parameters are there. One is the efficiency. Efficiency means time, how much time it is taking. One is the accuracy, that how accurate solution is there, means error. And one is the reliability. That reliability means how many times you have solved. Suppose 100 times you solve the problem. 100 times you solve the problem, and 100% you know the true solution. Suppose you know the true solution, and 100% times it is giving you the correct solution. The reliability is 100%. Out of 100 times, if it is 90 times it is giving you the true solution, it means its reliability is 90. Probabilistic algorithms, right? So its probability that it will give you the true solution is 0.9. So reliability is another criteria over which you can test your algorithm.
Okay.
Other than these three criteria, very recently I started using one, and started referring another criteria, which is called the signature of an algorithm. Signature of an algorithm. Signature of an algorithm means you solve this problem. Suppose it is a two variable problem or one variable problem, whatever. But let me just write like this: fx1, fx2 equal to suppose 2. Suppose this is the problem, and x1, x2 are in some range, suppose -5 to 5. I hope you understand that for this problem, since the objective function does not depend upon x1, x2, so every point in this -5 to 5 such a space, every point is a solution, is an optimal solution, because this 2 is not dependent on x1, x2. You solve this problem 1,000 times. If every time you are getting different points and your solutions are distributed uniformly in this search space, your algorithm is unbiased. Actually, the fourth point, I started adding biasedness. Algorithm is biased or not. So if all the points are distributed uniformly in the search space, you will say that the signature is uniformly distributed. This is called the signature. And therefore the algorithm is unbiased. But there may be, if the more concentration is here on the center, it means it is a center biased algorithm. Means if your problem has a solution at origin, it will be a good algorithm. But if it is not at origin, the algorithm will not be able to give you the answer. So the algorithm is biased towards the origin. So biasness can also be checked. So I prefer these 4 criteria now.
Okay. Sir, if the algorithm is unbiased, then we can say that it will be 100% reliable.
If it is unbiased, then no, not 100% reliable. Never. Even unbiased, the pure random search is unbiased. Pure random search, no intelligence. Pure random search is 100% unbiased. How you can say that it is reliable? No, it is not reliable. Reliability is a different thing. Unbiasedness is a different thing. Reliability can be obtained by repeating the experiments many times.
Thank you, sir. Thank you so much.
Okay. I hope I answered the questions. Okay, see you, sir. Should I stop now?
Yes, sir. Thank you so much, sir, for being with us. I
Thank
think the queries have been answered properly. And the candidates are very satisfied.
Thank you, sir. Thank you. My pleasure, sir.
Thank you, sir.
Okay. Good day, sir. Good day.